Hey students, welcome to lesson 8.8. Today we are going to translate words into expressions and expressions into words. It's connected to lesson 8.1. The difference today is we're going to make sure that we're putting the expressions in the correct order. Now that we know the order of operations, it's important that we do that. So let's look at the question for the day. It says, how can you translate words into expressions? What expressions show the weight of the mixed nuts after the weight of the jar is subtracted? So over here we have a glass jar on top of a scale, and as you can see the glass jar weighs 4 ounces, and we have a bunch of mixed nuts over here. And when you go to the grocery store, I don't know if they have one here in town, but some grocery stores have like containers of mixed nuts or other types of snacks, and you pay by the pound. And what they're doing here is trying to figure out how much the mixed nuts actually weigh. If you were to simply put a couple of scoops of mixed nuts in that jar, it's going to be heavier than the mixed nuts actually weigh, because the jar weighs 4 ounces itself. When we show this expression, we are going to use a variable. Remember, we know what variables are. Those are the letters or symbols that represent an unknown amount or an unknown number, and they can change or vary. So let's scroll down, and you can see this chart over here to the left is very similar to a chart you use in lesson 8.1. And it says, an algebraic expression is a mathematical phrase involving variables, numbers, and operations. The operation here, we'd have addition, a number plus 4. Now this is the word phrase, and this is what we're going to be looking at today. Word phrases and algebraic expressions. We're going to take an algebraic expression like this and turn it into a word phrase like this, or we'll be taking word phrases like these and making it into an algebraic expression like this. This table is going to be very useful for you today when you do your practice work. Notice the words that we're using here. Addition is a number plus 4. A number added to 4. For subtraction, we have a number minus 4, or a number less 4. Multiplication, we have 4 times a number. And for division, we have a number divided by 4. Now, if we look over to the right here, we know that the weight of the mixed nuts can change, right? They put 1 scoop in, it's going to be a different weight than if they put 2 scoops in, or 2.5 scoops, or whatever. But we do know the constant, the thing that's not going to change, and that's the weight of the jar. The weight of the jar is 4 ounces. So to find an expression here, the weight of the mixed nuts is going to be a number minus 4 ounces. And here's the expression that they're going to use here. So W minus 4, now W is going to represent the weight, minus 4 is the weight of the mixed nuts after the weight of the jar is subtracted. So going back up here, what they'd do is they'd put a scoop into the jar, they'd see the total weight, they'd subtract 4 ounces from it, and that's how they know how much the mixed nuts weigh. Alright, let's go over. I'm actually going to split screen this because we're going to use the word phrases over here. So in our guided practice today, it says, in 1 through 4, use a variable to write an algebraic expression that represents the word phrase. Number 1 says, twice the number of people. So that means I'm doing something here. I'm getting more people, aren't I? Twice the number of people. Well, what don't we know? We don't know the number of people. The number of people could possibly change, right? So let's use the variable p here. We're not sure how many people there are going to be. We'll represent that with p. Now, what are we going to do with that? Are we going to add that? Are we going to number plus 4? Do we have a number here to multiply? Not really, but twice means 2, right? Oops, means 2. That's a horrible 2. There we go. It means 2. twice. That means I'm doing it 2 times. Oh, okay, hold on a second. Look at multiplication, and I see the keyword here is times. Twice is 2 times something. I can say P times 2. Make that multiplication symbol a little bit better. That's a little circle. Another thing you can put here is 2P, or P times 2. Try not to put the X for multiplication because, again, that can be confusing. Let's look at number 2 here. 7 less than the current price. Alright, so 7 is a constant, $7 less than the current price. I'm going to look over here at my table. The word phrase, I'm looking for the word less than, plus, added, minus, less. There we go. So we're looking at subtraction over here. Now let's make sure that we put these in the right order, because it does matter. We can't, it's not like multiplication or addition where if we put them in reverse order, we'll still get the same product or the same sum. When we're subtracting, it's very important that we put the correct number in front of the other one. So, we have 7 less than the current price. So it looks like we're taking 7 away from the current price. So let's use a variable P again for the price, right? And we're taking 7 away. We're subtracting 7. So P minus 7. That would be the algebraic expression for that word phrase. Let's look at the next one. 8 more gumballs than Javier has. I see the word 8 more. So I'm going to go over to my word phrase list here. A number plus 4, a number added to 4, a number minus 4, a number less than 4, 4 times a number divided by 4. I see nothing here to help me out. But if I'm getting more gumballs, I know I'm not subtracting, I know I'm not dividing. I'm not making anything smaller, I'm making it bigger here. Am I multiplying? Something being multiplied multiple times, and it's not. It's just being added. Another word phrase over here we could put for addition is a number, or let me go. I'm going to unsplit screen this here to a single page display. Another thing we could do here, you might want to write this on here. You could write 4 more than a number. Alright, and more would be our word, our keyword that we're looking at here. So going back to the split screen again, 8 more gumballs than Javier has. So Javier has a certain number of gumballs. I'm going to use G as my variable. And I have 8 more than G, so I'm going to start with G and add 8 to it. G plus 8 will be our algebraic expression. Now if you put 8 plus G, it wouldn't make a difference. You'd still have the same answer, whatever you put in there for G, but I always like to make sure that my number sentences are in the correct order so they match up with the number sentence, or with the word phrase above. Alright, let's look at number 4. A number of students divided into 2 teams. This is pretty easy. It's telling us right here we are dividing, right? A number of students divided into 2 teams. So I'm going to use S as my variable here for the number of students. Now I know I'm dividing, and I'm dividing it into 2 teams. So S is being divided by 2. It's very important that we put this in the correct order. If I put it in the incorrect order, my answer will be way different than it should be. So a number here is S. This is the S, the variable. And it is being divided by 2. So the easiest way to do this would be S divided by 2. Another way you could do this is show it as a fraction, S divided by 2. That's an S, not a 5. S, there we go. S divided by 2. I like this way. It's not confusing for you. It's pretty flat out. S is being divided by 2 right there. Alright, I'm going to go back to my single page display. Let's look at numbers 5, 6, 7. Move me as well. Alright, number 5 says, what would the expression for the weight of the mixed nuts be if the jar was 8 ounces? Well, that'd be pretty simple, right? We have a weight that we're not really sure what it is. Oops. We have a weight, right? We're not really sure what the weight is. And now we're taking 8 ounces away, so we're just going to subtract 8. W minus 8. Number 6, communicate. Why is a variable used in the example on top? So, when they're talking about on top, we're looking at this expression right here. Why is a variable used right here? Well, that's pretty simple. The reason there's a variable used is because the weight can change. Because the weight, I'm going to put a little W in parentheses here, of the mixed nuts can change. Again, feel free to pause the video or rewind if you need to. Number 7, look for patterns. Write 2 word phrases that can be translated as 25 times P. Well, I'm going to go back to my dual page display because it's going to help me out. I'm going to use this chart over here to help me out with this. So I go to multiplication and I see that 4 times W, or 4W, is the multiplication in algebraic expression. How could I write it in a word phrase? Well, I could write a number times 25. Or I could write 25 times a number. Either way would be fine. Again, you can pause the video, rewind it, look it over again if you need to. This is just an extension of lesson 8.1. Again, just being very careful with the operation we're using, looking for keywords in the word phrases, and then making sure that we're putting the numbers and variables in the correct order in our algebraic expressions. Now your practice work is going to look something like this. Again, you can use, for example, number 8 says n plus 9. You're going to translate that algebraic expression into a word phrase. You can use the chart that was on the front page to help you out with that. And then you're also going to have to take these number phrases and turn them into algebraic expressions. If you have any questions, again, rewind the video, come and see me. Good luck.